In this fifth video tutorial on the VRS Simulator series, we will further explore the concept of loops. We'll try out a new feature in this version of the Virtual Robot Simulator, moving the arm up and down, and experiment with some basic motions. We'll learn first about all the motors in this incredible robot, and we'll try different movements. This lesson builds also on the looping skills we've developed in previous tutorials. By the end, we'll gain more experience programming repetitive arm motions in the simulator. The app uses 8 different motors to control various mechanisms and functions. Motor 1 controls the right front wheel, Motor 2 the front left wheel, Motor 3 the back left wheel, and Motor 4 the back right wheel for driving the base. Motor 5 moves the robotic arm up and down. Motor 6 controls a system to pick up and release game pieces. Motors 7 and 8 relate to launching and adjusting the angle of an airplane for a separate game function. The first 4 motors handle driving, while motors 5 and 6 manage game interactions. The last 2 motors enable an aerial launching ability. We've tried the first 4 motors earlier in the previous videos. Now, it's time to move forward and discover new tools. Let's try merging a loop within the 5th motor. Move the arm up and down, and let's do it for 10 times. To accomplish this, you can choose the block locating in the Actuators tab. Set Motor 5 to 0.3. Make sure you replace the front left to Motor 5 to make the arm goes up and down. Call the program to sleep for 0.8 seconds and then move the arm back by setting the parameter to -0.3 for 0.8 seconds. Initialize and start the program. Try to change the camera view by pressing W in your keyboard for a better visualization. Excellent work! You have now learned how to program vertical arm motion using Motor 5. We still have more motors and capabilities to explore in this robot simulator. In the next lesson, we will dive into controlling Motor 6, which handles picking up and dropping game pieces. The skills you gained making the arm move up and down will serve you well as we continue expanding the robot's functions. Onward to new frontiers with Motor 6. Before moving on to control Motor 6, it's important to highlight the physical differences between the 2 robot options in this simulator. Bot 1 is slightly larger in size and has a tilting arm but a fixed pixel holder that does not adjust angle, while Bot 2 is slightly smaller with a stationary, non-tilting arm but its pixel holder angle can change. In summary, Bot 1 has a movable arm and static pixel holder, while Bot 2 has an unmoving arm but dynamic tilting pixel holder. Keeping these variances in mind, such as the fact that Bot 1's arm shifts but its pixel holder stay fixed versus Bot 2's static arm but adjustable pixel holder, will help inform programming strategies and account for potentially different results when operating Motor 6 on the 2 distinct bot configurations. We keep the same code as before, trying to make the robot move forward, and then move the Motor 6 up and down to visualize the motor's movement. controls the launching mechanism for the airplane. The code first sets the motor power to one which tilts the launcher arm backwards and pulls the plane back into launch position. The adjust time parameter then determines how long it takes to cock back the launcher before firing. Higher value results in more potential energy stored for a stronger launch. Finally, the motor power is quickly switched to 1, which throws the plane forward for the duration specified by adjust time. In summary, Motor 7 first tilts the launcher backwards to load the plane, then forward to throw it. The adjust time value controls how far back the mechanism is pulled before being released. Similar to a slingshot, with the proper adjust time set, the plane can be launched at varying speeds and power. Mastering these parameters allows the bot to accurately control the flight trajectory. This motor enables the robot to pick up and fling the airplane over controlled distances. After launching the airplane with Motor 7, Motor 8 is used to adjust the angle of the plane in flight. First, the motor power is set to 0.5 to tilt the arm pixel holder down slightly. Next, the adjust time parameter controls how long this downward tilt occurs. A longer duration results in a greater change in angle. Finally, the motor tilts back up by setting the power to 0.5 for the same adjust time period. This sequence tilts the launcher down then back up again by a small amount to alter the angle of the airplane after it has been thrown. Modulating the tilt duration gives precise control over the plane's pitch and roll in the air. Motor 8 provides an additional level of control during flight, complementing the launch function of Motor 7. Together, these motors allow the bot to precisely guide the airplane's trajectory. Thank you for following along with this in-depth tutorial on programming all 8 motors in the VR's Robot Simulator. We started by learning to control the drive motors, motors 1 through 4, to maneuver the bot around its environment. Next, we explored using Motor 5 to move the robotic arm up and down. Motor 6 allowed us to pick up and release game pieces with the pixel holder. Motor 7 and 8 enabled launching and adjusting an airplane for aerial maneuvers. Each motor unlocks new abilities and allows us to make the bot move, build, and interact in more complex ways. This foundation, in controlling the core motors, will allow you to take the robot programming skills you've gained here and complete more advanced challenges. I hope you enjoyed learning alongside me. Thank you for watching.